Boom. Right. So as I said, I'm Sylvain. I'm VP Engineering of Algolia. I'm also the first employee, and I wanted to share with you a few tips about how we built a distributed search API, providing today 42 billions of API calls and operations every month. It has been a long journey since the day back in 2012 when we started a small search SDK for mobile devices until now, where we provide for 2,500 customers a search API. So before starting the talk, I just wanted to explain you again what is Algolia. So as I said, at Algolia, we are a hosted search API, meaning that we are providing developers with a search API that lets them implement the search inside their website or application. Imagine a technology that you could use inside your app or website to provide your end users the search they expect to find. They expect something like Google, like Amazon, something as you type that provide them with relevant results in a few milliseconds. We have a few examples on the screen. One of them is Birchbox, the other one is Jalopado. I took two e-commerce examples to just show you, and e-commerce is very simple, but we have obviously a lot of other customers. As a developer, to use Algolia, you go through 3 steps. The first one is you send us a copy of the data you want to search in. We are a hosted search engine. We are a SaaS search engine. So you will need to send us a copy of the data you want to search in. After that, we provide you, using the API or a UI, a way to configure your search engine, because obviously, since we are a generic API, and depending on your business, the relevancy might not be the same. We let you implement a search that will combine both textual relevancy, like you expect to find in any search engine, but also business relevancy, because that's what matters for your business. For e-commerce website, we will take probably the number of sales, but for a social network, we would take the number of followers. And for a media company, we'll probably take the number of times a video or a music has been listened to. We mix that together and we provide, through an API, providing JSON, a search API that lets you implement in your app or in your website that kind of experience. As you type some results, you don't even need to press the enter key. And again, that's the way we provide you with the Google or Amazon-like experience. Search is complex, and only Google and Amazon are currently nailing it. Even if you go to LinkedIn and you search for a first name space, a company name, it doesn't find it always, you know. We are providing you with technology that lets you search in all those attributes at once. You may not know us, but you may know our customers. Ooh, what is that? Those guys, Product Hunt, Digital Ocean, Periscope, Vivo, Twitch, Birchbox, Medium.com, those guys are all using Algolia to provide search to their end users. Today, as I said, we have a worldwide API. It's provided in 15 regions around the world, across 50 data centers, and that's about a bit less than 900 machines. As I said, last month, we provided something like 42 billions of API calls, and our customers are spread in 100 countries. Since day one, our DNA is really about performance. We want to provide you guys with a search that is blazing fast. We want you to have an answer in less than 100 milliseconds, network included. Meaning, wherever your users are on the planet, we will provide them with the same search experience. But that's not easy to do. And even Google and Amazon are struggling with it. Google say that every half a second of delay causes them 20% drop of traffic. Amazon say that every single 100 milliseconds of latency that they have costs them 1% in sales. I don't know if you know the revenue of Amazon, 1% is up. Boom. So as any software company, we start optimizing our software. We started, as some of you know already, as a mobile search SDK. So at that time, we were a C++ library interface in Objective-C or Java to run offline on mobile devices. Back in 2013, we pivoted the company to build an online SaaS company providing search through an API. We had that unfair advantage to have an SDK that was able to search into the cheapest Android phone with no RAM, no CPU, and obviously no disk. What we did at that time is we took that technology that we have designed for the cheapest Android phone, and we put them online on servers. Since day one, we optimized every single line of C++ code of that engine at the milliseconds level. Because we went from a mobile world, we wanted to have at every single keystroke some results and relevant results. On mobile devices, you don't press enter. You expect an as-you-type, a find-as-you-type experience. We brought that to the web and to your application, keeping the same core search engine. We didn't reinvent the whole wheel, so we host that search engine inside an Nginx process. And that Nginx process will accept the HTTP connections and provide your users with the search. But optimizing the software was not enough. Actually, search is really resource consuming. It needs a lot of CPU, a lot of RAM, and a lot of disk. So we had to optimize a lot how we deal with hardware. And today, most of the companies are building their SaaS website or SaaS service on the cloud. We didn't go for virtualized machine. We are not relying on Amazon, Rackspace, on any virtualized machine providers. It turns out that to be able to provide you with that kind of very fast search experience, we wanted to have the best CPUs. We have only CPUs that go up to 3.5 gigahertz. What you find today on Amazon or on Rackspace or any software virtualized provider is like 40 cores of 2 gigahertz. We went for maybe 8 to 12 cores, but very fast cores, because search is a lot also about single thread processing. Obviously, to keep the best search experience, you need to be fast, and to be fast, everything needs to be into the RAM. Google has multiple times the web inside the RAM. We do the same. We need to have your data into RAM. So we have at least 128 gigabytes of RAM per machine. Obviously, search is also a lot about persistence. So we have highly optimized SSD, and we select them very carefully because we burn so lot of them, so many of them, that today, when we want a new machine, we ask our providers, can I have a bare metal machines with that CPU, that RAM, and that specific SSD? Oftentimes they say, oh, we are used to provide you guys with that kind of SSD, and we say, no, we are going to burn it in 2 or 3 months. Can we have that one? It turns out that to accept that many connections per second, that many queries per second, remember that we provide as-you-type search, it's also a lot about internal kernel settings that will define how your Linux system will accept those TCP connections. We hit so many walls figuring out how to design servers that can handle so much load. Obviously, we wanted to have 100% uptime, and therefore we provide the service for every single users, including the free users that we have on 3 machines. This is not to spread the data across machines. It's really only for fault tolerance. So the 3 machines have all of them the data, but as you know, shits can happen and machine can go down. So we have 3 machines to make sure that if one dies, the others are still up. But then it's not done, because once you optimize the software, once you optimize the hardware, you have one issue, is that you're providing an online service. And if you don't optimize your network, it doesn't make any sense. If your users are not able to access your service, your API, in a few milliseconds, you won't leverage all the work that you have done. What we recommend everyone using Algolia is to go directly from their end user device be it the web browser or the mobile device, directly to our API without going through their backend server. It both offload their machines and make sure that the latency is the best. But as you may have, your users are probably worldwide. And if your API is hosted on a single region, you will have obviously issues because from anywhere in the world, they will need to reach your API. Imagine your API is hosted on the US East Coast. It will be okay for the US, even for the US West, because crossing the US is like 670 milliseconds of latency. But if you are from Australia, that's not gonna work. What we have done is an option called distributed search network, and it lets everyone, every single user of Algolia, every single customer of Algolia, replicate their search engine across all the regions that we have across the world, making sure that your users will always target the data centers that is the closest to your own position. And with that, we make sure that every single one around the world is able to get access to the data in a few milliseconds. I hope you enjoyed the Algolia Search API. I'm really happy, and everyone at Algolia is really happy to have you here. If you want to talk more about search, and I heard a lot of you need search in their app or website, just come to us. We'll be happy to have another chat after the talk off screen. If you guys have any questions.
So do we have any questions here? Yep. Ready? 1, 2.
What about the search algorithm itself?
So we have been doing search for the past 12 years. And what we discovered is that a lot of the search technologies are statistical based, meaning that statistically, they will try to figure out what is relevant, meaning how many occurrences of the word you have in the document, how many documents you have, how big is your document. But if you are LinkedIn, if you search for users, it doesn't make sense. All users have the same profile. And if I search for, okay, I don't remember your name. If I search for Sylvain, it doesn't make sense to show me, the Sylvain that has the longest title or the Sylvain that has the longest name. What I want to find is the Sylvain that is maybe the closest to me. When I'm on an e-commerce website and I search iPhone, I want to find the object that has iPhone in the title, and that is probably the most sold in the past 10 days or 1 month. So we do ranking like any other company. We provide a ranking algorithm that combines both textual and business relevance to provide you guys with the best search experience designed for your business.
Another question.
Can you say more about the different stacks you have, your technology? You didn't say too much about it. Do you have indoor technology? Do you use some Redis technology, some which runs in memory? Can you say more about it?
So we decided to build our engine from scratch. So all the data structures that we use inside a search engine are custom made in C++ by Julien, our CityO. In addition to that, yes, we use a lot of technologies. Redis is used a little bit for like real-time logs if we want to provide our users with the last API calls they have done. Storing it in Redis seems a good idea. Our search engine is closed source, but we provide a lot of details about how it works on our blog. On top of that, we have a lot of open source technologies and libraries. First, we provide every single customer with an API client that lets them implement Algolia inside their stack, be it in Python, Ruby, Java, PHP, whatever. On top of that, we have also integrations into major frameworks, be it Ruby on Rails, Symfony, Laravel, Django. We get on that. And on top of that, we have also integrations in major CMS or e-commerce solutions like WordPress, Magento. But the idea is really to provide a technology that is hosted, providing a search API, providing you JSON, so you decide how you want to take the data and display it to your users.
Can you tell us about the frequency of the replication and what technology you use to replicate?
So replication is tough, especially when you replicate across continents. When I replicate from US East to Canada, it's fine, it's a few hundred miles. When we replicate from US East to Australia, it's another story. What we decided to do is have a homemade solution that will be very, very simple, meaning that our users will always push the data that they want to index to a main region, and that main region will asynchronously replicate the data as fast as possible, but it will take some time from time to time, to the other replicated regions. It's homemade. We have a homemade distributed consensus on the main region that will just decide, because we have a 3-machine cluster, in which order to apply all the indexing job. But once that is done, we replicate asynchronously as fast as possible in real time the data. It means that if you add a new object to your main region hosted in US East, it might not be searchable in Australia, in the next second. It might take a few seconds, but still, most of the time, it's not a big deal to wait 10 seconds before it got indexed. Any other question?
I have 2 questions, in fact. The first one is, what is the volume of data you're storing today? And if you know, or at least something. And the second question is, what was your worst downtime in your history, and why did you have a downtime?
But you guys probably... 735 terabytes of data. Obviously, we have 2,500 customers, and all of them are sending us the data. Twitch, Periscope, those guys have hundreds of millions of data they send to us. Across 900 machines, it starts to be heavy. We do backups, and I don't remember the invoice, but yeah, it's a lot of data. Last downtime, at indexing, we had one downtime back in 2014. It was our first big issue, first major issue. The issue that we had at that time is that we had a very smooth way to deploy a new version of the machines, of the engine. We had a pretty poor way to roll back. It turns out that the issue we had at that time was not about a hardware or network issue. It was really a software bug. So it took 8 minutes to recompile the new version of the fix and deploy it. That was our biggest indexing downtime. Then from time to time, we had issues with the network because data centers, even the whole data centers can go down. Maybe not in the US, maybe not in Europe, but I tell you, in India, in Brazil, in Tokyo, it happens. What we have done since then is that we provide our customers with a multi-provider setups, meaning that the 3 machines that you have, at minimum 3 machines that you have, will be hosted on multiple providers. We can go up to 3 providers, default is 2, and those providers are using different data centers, different electricity providers, and different network providers. It means that if a nuclear attack happens in New York, it will be okay because we have also machines in Ashburn.
Some more questions. One, try. There.
People work now in Algolia, and among which, how many engineers and coders?
So as you understood, we provide a tech product. We are a tech company, and we provide a tech product to tech people. So engineers are the biggest part of our company. Today, we are 97, 98, about 60 in Paris, about 30 in San Francisco. We just opened our Atlanta office with 3 people and our New York office with 2 people. Across those 98 people, we have like 35 product/design/developers, plus 15 solution engineers. And today, the guys that helps our big customers to implement their solution, their Algolia experience on their website are definitely tech. So on top of the 35, you add 15, we are about 50 engineers, not including our CEO and CityO.
No more questions?
Cool.